Hello, grade 6. Now, I'm recording another experiment for you guys today. I don't honestly know that this one really needs to be recorded because hopefully you have the materials for this at home. But as usual, just in case you don't, I do want this to be still accessible to you, so I'm going to record myself performing the experiment. Now, this one is real simple. For materials, all that you need are 2 balloons and a refrigerator, which is in the next room, and I'm not going to move my camera to show you that right now. You'll just have to trust me. I have a refrigerator in this house. Now, the reason we have 2 balloons is for that very, very important principle behind science experiments. If we're going to change something, we want another example of what happens without that change. We want what's called control. So one of these balloons is our experimental balloon, and one of them is our control balloon. Simple enough. All right. For these purposes, I'm going to use pink as experimental, purple as control. The first step is just to inflate both of them to roughly the same size. I want them to be about the same. So we'll start with pink, and then I'll try and match it with purple. I hope the microphone doesn't make this sound horrible. Seems like a good size. These might have been coated in something in the factory. They taste kind of sweet. Not sure I like that. Oh well, here we are. Hopefully I don't have poisoning of some kind. If I post this video and then you don't see me for a few days, they may have coated this with something unsavory. I hope that's not the case. Anyway, here's a pink balloon. Let's see if the purple one tastes just as bad. And then try to make sure it ends up about the same size as this one. Yeah, it tastes bad too. Ugh. I think I made this one a little bigger, so we're going to try and match them, let some air out. I'm just eyeballing it here. It is just a guess, but I'm going to say these 2 balloons are now the same size. So let's tie this one off. I have 2 balloons with approximately the same amount of air, the same amount of my breath inside. Now I'm saying my breath, not air, because as you probably know, when any animal breathes in, their lungs do some work to convert some of the oxygen in the air and bring that into their bloodstream, while they then expel some carbon dioxide. That's just how we breathe. That's what we do. No one's lungs are 100% efficient. You still breathe out some oxygen, and in fact you can keep breathing your own breath back in for a while because there's enough oxygen in what you breathe out to keep you going. But there's less than when I started. So this is a little bit less air, less oxygen, and a little bit more carbon dioxide than regular air. But it's close enough for our purposes. I could still breathe this in for a little bit and be okay. All right, with 2 roughly equivalent balloons, 1 experimental and 1 control, I'm ready to begin the actual experiment. That is to leave the control alone. That control balloon, not a concern. That's there so that I can compare it tomorrow. The experimental balloon, however, is going to go in the fridge for about a day. It is 1:30 p.m. as I'm recording this. I'm going to take it out in the morning. That's going to be probably about 8:30. So not a full day, but about 3/4 of one. So I'm going to put this in the afternoon and remove it in the morning. I'm going to give it an overnight chunk in the fridge. So I'm going to stop this recording right now, go put this in the fridge, and tomorrow record part 2 of this where we see the difference between our control and our experiment. All right, it's been a day, so let's check on these balloons. I've still got my control here, just so you can see, after a day, balloons do shrink a little bit. A little bit of the air leaks out, some stuff will change, but for the most part, it kind of looks the same. However, our balloon that just came in from the cold, that just came out of the freezer, is looking a little bit smaller than it did before. Not dramatically so, but just putting them side by side, Oh, well, I gotta angle my camera down, but you can see, even just from the top here, this purple one, our control, is slightly larger. Zoom out a bit. Put him on my knees. Is slightly larger than our experimental balloon. Now, it's not dramatic. There's still a reasonable amount of air in here, and the air pressure around is not significantly different. But the density inside of this balloon has increased. The air inside of it has shrunk somewhat. And the longer I left it in the cold, and as it reached equilibrium with the air outside of it, we can see that the cold air is a little bit smaller, even though they started out the same. I'm going to put these away for a little bit. Now, what we've seen is that the density does change as the air gets colder. Now, for the actual scientific explanation of that, I'm going to leave that up to you. What makes the difference in density? And what sort of things are we looking at here? However, we can see there is a change. By leaving a balloon in the freezer overnight, it shrunk. Not a ton, but some. Which is why it's valuable to have a control. Otherwise, it would kind of look the same. But we are able to see that shrinking happens from the cold. And in fact, as I've been talking and as it's been sitting here, it is warming up a little bit. Now, I got it out of the freezer a few minutes before I started filming, so it's already had some time to warm up. I'm going to give it a couple. I'm going to pause recording for about 5-10 minutes, and then we're going to come back and we're going to take a look at what happens once it's been warmed up. Let's see what happens while we're waiting on the observations. Alright, it's been a few minutes now, so let's take a look at our experimental balloon once again. As it has been sitting in the warm room, it's actually expanding back up to its, maybe not its original size, but to be a comparable size again with our control balloon. The warm air is spreading out again. It's exerting a bit more pressure on the balloon and spreading out to fill up the same space it had filled out before. Neat. So, now that we've seen this, what might you expect? What is happening? The explanation is up to you. This is for your observations. Now, hopefully, you're able to write your conclusions based on that. All right, that's it, guys. Take care. Peace.